Okay, let's start with part 2 now. We'll be applying some methods that we learned previously using pandas. So we have some restaurants data and we'll be joining them using the merge function of pandas library. So as the first step, we first load the restaurants data which you already downloaded in the directory. You can see using the .info that there are 4 columns with ID, cluster, name and city. There are 858 non-null values in each column, and the data type are integer and objects. Okay, we can see the first 10 rows. Okay, and the problem with this data is that there are some redundant or similar rows which are not exactly identical but very similar, so we want to remove those rows, or we want to clean this data set by using pandas. Okay, so we can now we only have one data frame, and we want to merge this data frame with itself, which is called equi-join, which is to find and we use equi-join to find pairs of duplicate restaurant records. That is, we join the data to itself on the cluster column. So the all the so we would get a bigger data set now. So we use the merge it on the cluster column, and let's see some rows of this new data frame, which is called clusters. Now each row is joined with a row which is similar to that in terms of the cluster column, and because there are the same column names are in both the samples that were joined together, so the pandas automatically convert the column names to differentiate them to _x. So for example, we have id underscore x and id underscore y, name underscore x and name underscore y. Okay, but in this, the problem with this newly created or this merged data frame is that there are several extra records. For example, each row is because it's exactly identical to itself, so they are also merged together to form which is not necessary. So we can remove all the columns where id underscore x is exactly equal to id underscore y. And another problem with this is that it gives both pairs A and B A. So if a row matches with another row, so let's say the first row is row A and the second row is row B, then row B also matches with row A, so we would get 2 matched records instead of 1. So we can remove them as well. So let's do that. So let's first remove the columns, the rows with the exactly same IDs for id underscore x and id underscore y. It's clusters where with only clusters dot id underscore x is exactly equal to is not equal to, because you want to remove all of the equal. And then we can see how these clusters look like. So these are new clusters. So before that we had okay, before removing these columns, rows, we in the restaurants data set we had 858 rows, but now we have 212 rows. Okay, so so now we have 212 rows in our filtered table. Another thing that we can do is we can also remove um, uh, uh, the entries with matching outputs. For example, because with problems like we get both AB and BA by, let's call it cluster underscore F, filtering it further. So clusters dot drop underscore duplicates on subset is equal to cluster cluster. Okay, so all the entries, redundant entries with the same cluster cluster name would be removed. Then length of clusters underscore F would give us the number of filtered rows, the unique rows with a unique cluster ID. Okay, so how many rows are there in your filter table? There are 106. Okay, then we have fuzzy joints where this an optional part of the lab. So if you want to do it, go ahead, and otherwise it's okay to leave it. So fuzzy join actually means that instead of equijoin, which looks for the exact match, fuzzy join is where we join two records when they are almost similar, not necessarily exactly similar, or if we apply a function on a certain instant or a certain record, and it becomes equal to or similar to another record, we can use them to do fuzzy joins. Okay, next is for checking the string similarity. We there is which is called edit distance. We use a Python library which is called Levenstein. So if you have if you don't you can check if the Levenstein library is already installed by running this. Otherwise, you can install it by using corda install function, and then this would be actually used to calculate the difference between two strings. So for example, if we okay, we would use this later. Okay, let's join every record in the first table with every record in the second table. So that is we want to have a Cartesian product of the data with itself. So for example, if there are 100 entries in a table, the resultant join would get us 100 times 100 entries. So because each entry would be matched with all other entries, would be joined with all other entries in the table. So for that purpose, we generate a dummy variable, a dummy column, where all the values are zeros. So that there is a matching value in all the entries in all the records. Okay, so first we create this new we attach a new column with all zeros to the restaurant um, data frame. Then we merge the data frame with itself on this new column. Then we can remove this from the this column because we no longer needed. We just needed the joint data set where all entries are put together with all entries from the table. So if you run this, okay, we change this a bit. Okay, it gives us a number which is basically equal to the length of the new data set is actually equal to the square. And let's first print the first 10 entries of the new data frame. You can see with ID x equal to 560, multiple rows are joined together. So that is, if with each ID, with respect to ID, with each entry, all other entries are joined together. And then from this data set, we can remove using the IDs, we can remove the extra recorded pairs, which are actually the pairs with the same ID. For example, we can do that by product. Okay, let's do this. Product is equal to product when product ID underscore x is equal to product ID underscore y. Okay, next we can add a column to this product after filtering, which measures how similar each pair of record is. So we are using this, would be using this library L or Levenstein. So for example, if first let's run this. So there is, between these two strings, there is a change or a difference of one character only, which is E and A. So the edit distance is equal to 1. So we can use this edit distance to find the distance between each matching pair in this product data frame. So that is, and by adding a new entry by a new column to the original data set. So that is where and we have the string columns names. So where name underscore x and name underscore y would be compared for each match, and the edit distance would be calculated. Okay, then we filter the Cartesian product based on when the joint criterion is similar enough. And by similar enough, we mean that the edit distance is within a threshold. So for example, smaller than a maximum threshold, a limit, or so for that. And then we find, so let's try this now. We define a function's accuracy, which takes the argument maximum underscore distance. We would call the entry similar if the distance provided by the edit distance is less than the maximum or the threshold. So this would give us all the entries, all the matching entries, where the entries are similar enough, or from all the pairs where the pairs are similar. Then the correct would give us the number of entries among the similar ones where they are exactly the same. So in terms of the clusters. Then we can calculate the precision by dividing the true positive by the number of all positives, and recall by dividing the true positive divided by all the entries. And then we can do that for a range of maximum distance, for a range of threshold, and calculate precision and call for each threshold. So let's plot this. So as you can see, okay, we made a mistake here. Okay, this should be instead of equal to, it should be not equal to. We want to keep all the records where the IDs are not similar and remove all the records where the IDs are similar. So this would be a better okay. Now moving on, calculate the distance, and let's see how we can now, let's see them. And change it from here again. Okay. Now it should work, I hope. Okay, so because it's using a for loop, so that's why it would take some time. Okay, now we have the edit distance for each pair. Okay, now let's try this one again. Yes, okay, you can see that with increasing threshold, the precision keeps decreasing, but the recall almost keeps increasing. And they meet at a certain point, which is actually the best point. So, for example, so the purpose is basically to have a higher accuracy in terms of the actual match and the match that we estimated using the threshold distance. So if we increase the threshold distance, that means there would be more entries in this. There would be more entries, more pairs which would be similar, and the number of exact matches would also increase. So that's why our precision keeps increasing a little bit. But then it also increases the number of false positives, so which is why our recall is getting decreased. Okay, we can also see precision versus recall to see what's the best trade-off between because like we would like to have a higher accuracy, but and a higher recall, but also a large enough precision as well. So so to see which one is the best option, we can check, we can plot using scatter P versus all R, and let's label them. Precision on the x-axis, recall on the y-axis, and let's also put a limit range on axis. Zero to 0 and okay, it's by lab, not by plot. By plot is another library. best bit is where we have a high precision and high recall is okay, somewhere around here at this point. So where we have almost the precision recall both are around 0.75 to 0.8. Okay, that's it from my side. Make sure that you practice on these exercise by yourselves. If you have any questions or any issues, you can ask on the MS Teams, and please try to remember to upload your response on MS Teams as well. Thank you very much.